With the means to test whether we are clicking on our light switch or not nearly complete, we will also need to make sure that the associated lights also know what to do when asked to switch either on or off. Inside the content browser then, we will want to locate our wall light static mesh actor, and after double-clicking to open it up, just make sure that we are looking at its event graph. As with our automatic doors, this blueprint contains a number of actor types, and so not only do we have our static mesh actor, this being the light housing, but we also have two light actors providing the illumination. The lights are set to be movable, which means that we can change the intensity at runtime, whereas static lights wouldn't work in this particular situation. We will need to access the two light actors properties then, and so from the Components tab, let's drag out a reference from the Spotlight and Spotlight 1 components. Just like the sliding doors in our last example, we now have a reference to each light in the blueprint, which means that we can change them either individually or together depending on the needs of the project, although in this instance we will control them together. Before we set up the light switch, let's go ahead and tell our lights what to execute by right-clicking in some empty space and then performing a search for custom event, after which we can choose to add the custom event option and give it the name switched, meaning this custom event can now be accessed from outside this blueprint and told to execute. Whatever we add after this node now will run every time the blueprint is told to execute the switched custom event. Let's continue setting up the logic for the flow then by dragging from the custom events execution port, and then searching for and adding a flip-flop node from the flow control section. In this instance, we know that the lights we will be controlling are only going to be either on or off, hence the flip-flop node, which does just as it says, and switches between its A and B execution ports each time that it is called into action. We need to tell the flip-flop node what to do still, and so let's drag out from our Spotlight reference, type set intensity into the search field, and then add the node of the same name from the light section. After which, we can pipe our Spotlight 1 into its target slot as well, setting its intensity to a value of 0. As you can see, we are able to control both lights with a single set intensity node here, thereby making the blueprint really efficient. It should be noted that our lights are starting with a positive intensity value, and so are turned on, meaning we need to make sure the first flip-flop, so the node's A output, sets the intensity to 0 or off. If we start with lights that are off by default, of course, then we will need to reverse this order. To enable us to turn the lights back on, we can once more drag out from the Spotlight reference, type set intensity into the search field again, and then add another node of the same name. After which we can pipe our Spotlight 1 reference into its target input and set its intensity value at 200, essentially making it so that if the lights are off, then they will be turned back on. Now, if we wanted to alternate between top and bottom lighting, we would simply make sure that one of the lights in the actor starts with an intensity of 0, and then remove the appropriate light from each set intensity node. When we press the switch then, we would change from up lighting to down lighting. Now, this can be a fun exercise, and so maybe something that you can try in your own time once the blueprint is complete. Again, don't worry if it doesn't fully make sense to you if you are new to blueprints, however. Coming back to our example, at this point in time, nothing will actually execute, and so let's pipe our A execution port from the flip-flop node into the first set intensity node, and the B execution into the second set intensity node. Now, whenever the blueprint is told to execute, it will flip-flop between the two intensity states that we have created. These, of course, being off and on. What we have seen here, though, is that we can set up custom events per blueprint that can be called into action any time we want. Although it may seem like a lot to take in at first, the simple overall nature of blueprints means that once we have worked with the system for a while, the nodes and connections will start to make much more sense.